You can count on us like 1, 2, 3, we'll be there. And we know what you need and we are count on me. We will help you with accounting. Let's learn together to achieve our dreams.
Hello everyone! Welcome to Account on Me Season 2. I am Adylaine, Llaban, and together with Jedidiah Tenorio, we will be your study partners for today's video. So get ready and let's start accounting. Today we will be discussing Chapter 6 Effective Interest Method, Market Price of Bonds. And by the end of this discussion, we are expecting you to understand the effective interest method of amortizing premium and discounts on bonds payable, to distinguish the effective rate and nominal rate of interest, and to know and understand the computation of market price or issue price of bonds payable. Effective interest method. I am pretty sure that you already have an idea about this since it is also part of the subject Intermediate Accounting 1. So to review, according to Philippine Financial Reporting Standards 9, effective interest method is a method used to amortize the discounts and premium of bonds payable and the bond issue cost. This is also called the interest method and scientific method. In this method, we are using two interest rates which are nominal and effective rate. When we say nominal rate, it is the stated rate while the effective rate is the market rate. Effective rate is also the rate that discounts estimated cash future payments through the expected life of the bonds payable to the net carrying amount of the bonds payable. Please remember this, if the bonds are sold at face amount, the effective rate is equal to the nominal rate, and if it is sold at a premium, the effective rate is less than the nominal rate. And if it is sold at a discount, the effective rate is greater than the nominal rate. These are the formulas that we are going to use in the effective interest method, so please familiarize yourself with this. Before amortizing premium and discounts, we need to find first the nominal interest and effective interest. Nominal interest is the same with interest paid, and effective interest is the same with interest expense. So to find the nominal interest, we just need to multiply the nominal rate and the face amount of the bond, while in effective interest, just multiply the effective rate and the carrying amount. Please take note that the carrying amount of the bonds changes every period as the amount of premium and discount is amortized periodically. Now we know how to find the nominal and effective interest. So to find the premium amortization, just subtract the nominal interest and effective interest. While in discount amortization, it is effective interest minus nominal interest. Now let's solve a problem about effective amortization of discounts. You can open your book on page 200. On January 1, 2021, an entity issued 2-year 8% bonds payable with face amount of 1 million pesos for 964,540 pesos, a price which will yield a 10% effective interest cost per year. Interest is payable semi-annually on June 30 and December 31. So to review only, these are the formulas that we are going to use to complete the schedule of amortization for discount. It is the same formula mentioned on the previous slide, so interest paid is equal to the nominal rate times face amount of the bonds. Interest expense is equal to the effective rate times carrying amount. Again, to find the discount amortization, we just need to minus the interest expense and the interest paid. And to find the carrying amount, preceding carrying amount plus discount amortization. These are the journal entries for the year 2021. On January 1, debit cash 964,540, debit discount on bonds payable 35,460, and credit bonds payable 1 million. For June 30, for the payment for semi-annual interest and periodic amortization of discount, debit interest expense for 48,227, credit cash for 40,000, and credit discount on bonds payable 8,227. For December 31, debit interest expense 48,638, credit cash for 40,000, credit discount on bonds payable 8,638. Now let's try a problem about effective amortization of premium. On January 1, 2021, an entity issued 3-year 12% bonds payable with face amount of 1 million for 1,049,740 pesos, a price which will yield a 10% effective interest cost per year. The interest is payable annually every December 31. For the schedule of amortization for premium, just use the same formula to get the interest paid and interest expense. And to solve for the premium amortization, interest paid minus interest expense, and for the carrying amount, receiving carrying amount minus premium amortization. These are the journal entries for the year 2021. On January 1, debit cash for 1,049,740, credit bonds payable 1 million, and credit premium on bonds payable 49,740. On December 31, there are 2 entries because we journalized the annual payment of interest and the premium amortization separately. So on December 31, debit interest expense 120,000, credit cash 120,000, and debit premium on bonds payable 15,026, and credit interest expense 15,026. Now let's talk about the market price or issue price of bonds payable. Market price is equal to the present value of bond liability plus present value of future interest payment using effective rate. The present value of the principal bond liability is equal to the face amount of the bond payable times the present value of 1, factor at the effective rate for a number of interest period. And the present value of the future interest payment is equal to the periodic nominal interest times the present value of an ordinary annuity of 1, factor at the effective rate for a number of interest periods. In order to understand it, let's try the illustration on page 203. For this illustration, the face amount of bond payable is 4 million, nominal rate 6%, effective rate 8%. The bonds are issued on January 1, 2021 and mature in 4 years on January 1, 2025. The interest is payable annually every December 31. Since it is payable annually, there will be 4 periods from 2021 to 2025. The relevant present value factors are present value of 1 at 8% for 4 periods is 0.7350, and present value of an ordinary annuity of 1 at 8% for 4 periods is 3.3121. Now let's solve for the total present value of bonds payable. We need to find first the present value of principal and the present value of annual interest payments. And to solve for the present value of principal, just apply the formulas that I mentioned a while ago. So multiply the face amount 4 million and the present value of 1 at 8% for 4 periods, which is 0.7350. The present value of principal would be 2,940,000. Then, let's solve for the present value of annual interest payment, but before that, we need to solve first for the periodic nominal interest. So, a face amount of 4 million times 6%, which is the nominal rate, the periodic nominal interest would be 240,000. Now that we have the value of periodic nominal interest, the next thing to do is to multiply it to the present value of an ordinary annuity of 1 at 8% for 4 periods. So 240,000 times 3.3121 is equal to 794,904. Now let's find the sum of the present value of principal and the present value of annual interest payment to find the total present value of bonds payable. So 2,940,000 plus 794,904 is equal to 3,734,904. Now let's solve for the discount on bonds payable. We just need to find the difference of the face amount and the market price of the bond. So 4 million minus 3,734,904, the discount on bonds payable would be 265,096. Now let's try another illustration with bonds payable at a premium. The face amount of bond payable is 5 million, nominal rate is 12%, the effective rate is 10%. The bonds are issued on January 1, 2021 and mature in 3 years on January 1, 2024. The interest is payable semi-annually every June 30 and December 31. Since it is payable semi-annually, there will be 6 periods in 3 years. So the relevant present value factors are the following. the PB of 1 at 5% per 6 periods, 5% because it is the half of 10% since it is semi-annually. The value of it is 0.7462. And the present value of an ordinary annuity of 1 at 5% for 6 periods would be 5.0757. To find the present value of principal, just multiply 5 million and the 0.7462. The present value of principal would be 3,731,000. The present value of annual interest payment, we need to find first the value of semi-annual interest payment. So 5 million times 6%, 6% because since it is semi-annual, we just need to divide the 12% nominal rate by 2. The semi-annual interest payment would be 300,000. So to find the present value of annual interest payment, 300,000 times 5.0757 is equal to 1,522,710. Add the present value of principal and the present value of annual interest payment. The total present value of bonds payable would be 5,253,710. And to find the premium on bonds payable, just subtract the market price 5,253,710 and the face amount 5 million. So the premium on bonds payable would be 253,710. So before we move on to the next slide, there is the way to find the present value factor through an ordinary calculator. So please get your calculators and follow these steps. So let's try to find the present value factors from the previous illustration. So the first thing to do is to enter 1.05 because it is the present value of 1 at 5%. Second, press the division sign twice. Then, press the equal sign for the number of interest periods. Since the interest period is 6, we just need to press the equal sign 6 times. Then the result will be 0.7462. Next, deduct 1 from the result in number 4. The result will be negative 0.2538. Then, press the plus minus sign to remove the negative sign. Seventh step is to divide the result by 0.05. Then the result would be 5.0757. Now let's try the serial bonds payable. These are the given data. Face amount 3 million, nominal rate 12%, effective rate 10%. The date of issue is on January 1, 2021, and the annual payment every December 31 amounting to 1 million. Interest is payable annually on December 31. The present value of 1 at 10% for 1 period is 0.9091, 2 periods 0.8264, 3 periods 0.7531. So to find the total present value of bonds payable, let's use this table. On the first column, we can see the dates wherein the annual payment has been done. On the second column is for the principal payment amounting to 1 million. The third column is for the interest payment, and in the bottom of the slide, you can see how we got the values for interest payments. On the year 2021, just multiply 3 million to 12% nominal rate. That would be 360,000. On December 31, 2022, 2 million because 1 million is already paid last year. The remaining bonds payable is 2 million. Then multiply it by 12%, that is 240,000. And for the year 2023, the remaining balance is 1 million times 12% equals to 120,000. The fourth column is for the total payment. You just need to find the total of principal payment and the interest payment. Fifth column includes the PB of 1 at 10% for every period. Then the last column is for the present value. You only need to multiply the total payment and the PB factor. So to find the present value of bonds payable, just add all of the present value written in the sixth column. The sum would be 3,102,568. And to find the premium on bonds payable, find the difference between the total present value of bonds payable and the face amount. So 3,102,568 minus 3 million, that would be 102,568. Now let's look at the table of amortization. It is different from the schedule of amortization for premium and discount since there is an additional column for principal payment in serial bonds. So to complete this table, we only need to apply the formulas flashing on your screens. For the interest paid, face amount times nominal rate, interest expense preceding carrying amount times effective rate, premium amortization, interest paid minus interest expense, and carrying amount is equal to preceding carrying amount minus premium amortization minus principal payment. So here is the journal entries for the year 2021. The first journal entry for the issuance of bonds payable: debit cash 3,102,568, credit bonds payable 3 million, credit premium on bonds payable 102,568. Second journal entry for the payment of interest: debit interest expense 360,000, credit cash 360,000. And the third journal entry is for the amortization of premium on bonds payable: debit premium on bonds payable 49,740, credit interest expense 49,740. The fourth journal entry would be for the payment of principal: debit bonds payable 1 million, credit cash 1 million. Now that we're done discussing the market price or issue price of bonds payable, here's Mr. Jedidiah Tenorio to discuss the bond issue cost.
Now, I'm going to discuss about effective interest method bond issue cost. So, before we proceed with the topic, first let me define what transaction costs are. Transaction costs are fees and commissions paid by agents, brokers, advisors, and dealers, levies by regulatory agencies and securities exchange, as well as transfer taxes and duties. So one example of transaction costs is the bond issue cost. According to the PFRS 9, transaction costs which are directly attributable to the issue of financial liability shall be included in the initial measurement of the financial liability. Thus, transaction costs, including bond issue costs as well as premiums and discounts, are involved in the calculation of the effective interest rate. And under the effective interest method, the bond issue cost increases or is lumped with the discounts on bonds payable and decreases or is netted against the premium on bonds payable. And for us to visualize and understand the concepts more clearly, here is an illustration for discounts on bonds payable. On January 1, 2021, an entity issued 3-year bonds payable with face amount of 10 million pesos and 9% stated rate. The bonds mature on January 1, 2024 and interest is payable annually on December 31. The bonds are issued at 9,751,210 pesos with an effective yield of 10% before considering the bond issue cost, and the entity paid bond issue cost of 239,880 pesos. So this will be the computation to get the net proceeds. So the face amount of bonds payable is 10 million, then deducted by the discount on bonds payable of 248,790 to get the issue price of 9,751,210. So how did we get the discounts on bonds payable of 248,790? First, we will be getting the discount by deducting the face amount of bonds payable of 10 million by the issue price of the bonds before considering the bond issue cost of 9,751,210 pesos, which will result to the value of 248,790. And the issue price of 9,751,210 will be deducted by the bond issue cost of 239,880, which will result the net proceeds of 9,511,330. And as given, the original effective rate is 10%, but because of the bond issue cost, the new effective rate must be higher than 10%. And now we have to find an effective rate that will result to a present value of bonds payable equal to the net proceeds that we have computed in the previous slide, which amounted to 9,511,330 pesos. And accordingly, the effective rate cannot be computed algebraically, but we can acquire it by means of trial and error or the interpolation process. And since the new effective rate should be higher than 10%, we will try to use the effective rate of 11%. So by interpolation and using an effective rate of 11%, the present value of 1 for 3 periods is 0.7312, and the present value of an ordinary annuity of 1 for 3 periods is 2.4437. you can acquire these values by using a mathematical table of present value of a single payment and present value of an ordinary annuity. So the present value of the bonds payable using an interest rate of 11% is computed as follows. So the present value of principal computed by multiplying 10 million principal amount by the 0.7312 present value of a single payment of 11%, resulting to 7,312,000. And the present value of interest payments, which is computed by multiplying 900,000 annual interest payments by 2.4437. So we get the 900,000 annual interest payments by multiplying the principal by the given stated rate of 9%. So the present value of interest payments is 2,199,330. Adding the two values, we would get the total present value of 9,511,330. Coincidentally, the present value of the bonds payable is equal to the net proceeds, both amounting to 9,511,330. And thus, the new effective rate to be used in this problem is 11%. So, next would be the journal entries for 2021. In January 1, the entry is to record the issuance of bonds payable. So, we debit cash 9,511,330. Debit discounts on bonds payable 488,670, and credit to bonds payable 10 million. So how did we get the value 488,670 in the discounts on bonds payable? As stated earlier, under the effective interest method, the bond issue cost is lumped with the discount on bonds payable. So the amount of the bond issue cost of 239,880 is added to the amount of the discounts on bonds payable of 248,790, thus resulting to the amount of 488,670. Next, journal entries. In December 31, to record the annual interest payments, so interest expense of 900,000 debit, which is acquired by multiplying the principal by the 9% stated rate, then credit cash 900,000. And in December, another entry for December 31, to record the amortization of the discount on bonds payable using the effective interest method. So we debit interest expense of 1 million for we debit the interest expense of 146,246 and credit cash 146,246. So how did we get the amortization of the discounts on bonds payable? The computation is as follows. So the interest expense that is acquired by multiplying the 9,511,330 net proceeds by 11% new effective rate, which results to 1,046,246, and the interest paid acquired by multiplying the principal by the 9% stated rate. So the interest expense of 1,046,246 deducted by the interest paid amounting to 900,000, the amortization of discounts on bonds payable is 146,246. You can also acquire the new effective rate by using a financial calculator. So these are the steps. First, you enter negative 10 million pesos, which is the cash outflow for principal, then press FV. 2. Enter negative 900,000 pesos, which is the cash outflow for interest, then press PMT. 3. Enter 3, which means maturity, then press N. Number 4, enter positive 9,511,330 net proceeds, which is the net proceeds, then press PV. Then press comp, which means compute, and I%, which means effective rate. Then press XA or execute. Then the financial calculator will yield an answer of 11%. You can pause this video if you want to try to solve. You can just follow these steps and you will get the new effective rate of 11%. Here is another illustration for discounts on bonds payable. On January 1, 2021, an entity issued 5-year bonds payable with face amount of 10 million at 95. The nominal rate is 10% and the interest is payable annually on December 31. The bonds mature on January 1, 2026 and the entity paid bond issue cost of 200,000. So here's the computation for the net proceeds in this problem. The face amount of bonds payable of 10 million deducted by the discount on bonds payable, which is computed by multiplying the principal 10 million by 5% discount, which is 500,000. Then we will get the issue price of 9,500,000. Also deducting the issue cost from the issue price. Also deducting the bond issue cost from the issue price. So 9,500,000 minus 200,000 results to a net proceeds of 9,300,000. Since the bonds are issued at a discount, the new effective rate should be higher than the nominal rate of 10%. So again, we will be using an effective rate of 11%. So the present value of 1 for 5 periods is 0.5935 and the present value of an ordinary annuity of 1 for 5 periods is 3.6959. Computing for the present value of the bonds payable using the 11% effective rate, the present value of the principal, 10 million principal times 0.5935 equals to 5,935,000. Then present value of interest payments, which is 1 million times 3.6959. So we got the 1 million by multiplying the principal by the nominal rate of 10%. So we get the present value of interest payments of 3,695,900. So adding the two values, we get the total present value of 9,630,900. The net proceeds with a value of 9,300,000, which was computed in the previous slides, is lower than the present value of the bonds payable using the 11% interest rate. Thus, the effective rate must be higher than 11%. So we will be doing another interpolation, but now we will be using an effective rate of 12%, which is higher than 11%. The present value of 1 for 5 periods is 0.5674, and the present value of an ordinary annuity of 1 for 5 periods is 3.6048. And again, we compute for the present value of the bonds payable using the 12% effective rate. The present value of principal is 5,674,000 and the present value of interest payments is 3,604,800. Thus, the total present value by adding the two values results to 9,278,800. And now, the net proceeds of 9,300,000 is higher than the present value of the bonds payable as computed using the 12% interest rate. Thus, the effective rate must be lower than 12%. And since the effective rate should be higher than 11% but lower than 12%, it means the effective rate must be between 11% and 12%. So, we are going to interpolate the differential between the 11% and 12% using the following equation, x as the unknown effective rate. So the equation is x minus 11% all over 12% minus 11%. Then we substitute the present values applicable to each of the rates. We will be substituting respectively the present values computed previously using the rates. So by substitution in the equation, the new equation would be 9,300,000 minus 9,630,900 all over 9,278,800 minus 9,630,900. So the 9,300,000, which is equal to the net proceeds, is the present value of the unknown effective rate. 9,630,900 is the present value computed using the 11% effective rate, and 9,278,800 is the present value computed using the 12% effective rate. So the equation will result to 330,900 over 352,100, which is equal to 0.94. And the differential, which is 0.94 between 11% and 12%, is then added to 11%, resulting to a new effective rate of 11.94%. Again, for those with financial calculators and or who wants to try to solve for the effective rate, you can pause this video and follow the steps shown on your screens and you will also get the answer of 11.94%. Next are the journal entries. For January 1, the entry is to record the issuance of bonds payable. We debit cash 9,300,000, debit discounts on bonds payable 700,000, and credit bonds payable of 10 million. And again, like in the previous illustration, we are going to add the amount of bond issue cost of 200,000 to the amount of the original discount on bonds payable of 500,000, resulting to 700,000. Entry for December 31 to record the annual interest payment. So the interest expense acquired by multiplying 10 million principal by 10% nominal rate, which is 1 million. Then credit cash 1 million also. And another entry for December 31 to record the amortization of the discount on bonds payable using the effective interest method. We debit interest expense of 110,420 and credit cash 110,420. And the amortization of 110,420 was computed as follows. Interest expense acquired by multiplying 9,300,000 net proceeds by 11.94% new effective rate. The result is 1,110,420, and the interest paid acquired by multiplying the principal by 10% nominal rate, which is equal to 1 million. Then we deduct the interest paid from the interest expense. We get the amortization of discount on bonds payable, which is equal to 110,420. Next illustration is for premium on bonds payable. So this is the problem. On January 1, 2021, an entity issued 5-year bonds payable with face amount of 10 million at 105. The nominal rate is 10% and the interest is payable annually on December 31. The bonds mature on January 1, 2026, and the entity paid bond issue cost of 200,000 pesos. So the following is the computation for the net proceeds. Face amount of bonds payable is 10 million. Then the premium on bonds payable is 500,000. We got the premium by multiplying 10 million face amount of bonds payable by 105%. Then after adding the two, we got the issue price of 10,500,000. Then we deduct the bond issue cost of 200,000 to get the net proceeds of 10,300,000. Under the effective interest method, the bond issue cost is netted against the premium on bonds payable. This concept will be applied later in the process. Since the bonds are issued at a premium, the effective rate must be lower than 10% nominal rate, which is opposite from discount on bonds payable, where effective rate must be higher than the original rate, as what we did in the previous illustrations. So we would be using the 9% effective rate, which is lower than the original 10% rate. So by interpolation, using an effective rate of 9%, the present value of 1 for 5 periods is 0.6499, and the present value of an ordinary annuity of 1 for 5 periods is 3.8897. Then we compute for the present value of the bonds payable using the 9% interest rate. So the present value of principal, which is computed by multiplying 10 million principal by 0.6499, so we got 6,499,000 present value of principal. Then the present value of interest payments, which is acquired by multiplying 1 million annual interest payments by 3.8897. So the 1 million annual interest payments is again computed by multiplying the principal by the 10% nominal rate. So we got a present value of interest payments of 3,899,700. So we add the two values, we get the total present value of bonds payable at 10,388,700. And since the net proceeds of 10,300,000 is lower than the present value as we computed, using the 9% interest rate, thus the effective rate must be higher than 9%. And since the effective rate should be lower than 10% but higher than 9%, then the effective rate must be between 9% and 10%. And we will get the differential between 9% and 10% using the following equation. And yeah, we will be interpolating the differential using the following equation, x as the unknown rate. So the equation is x minus 9% all over 10% minus 9%. Then we again substitute the present values applicable to each rates. 10,300,000 minus 10,388,700 all over 10 million minus 10,388,700. 10,300,000, which is equal to the net proceeds, is the present value of the unknown effective rate. 10,388,700 is the present value that we previously computed using the 9% effective rate, and 10 million is the face value of the bonds payable at 10% rate. So the answer is 0.23, which is the differential between 9% and 10%, which would be subsequently added to 9%, resulting to an effective rate of 9.23%. And again, for those who want to try and solve for the effective rate using a financial calculator, you can pause this video and follow the steps shown on the screen, and you will also get the answer of 9.23%. So next are the journal entries. The journal entry for January 1 to record the issuance of bonds payable. We debit cash 10,300,000, credit bonds payable 10 million, then credit premium on bonds payable 300,000. As stated previously, which is the concept that under the effective interest method, bond issue cost is netted against the premium on bonds payable. And we got the value of 300,000 by subtracting 200,000 bond issue cost from the original premium on bonds payable of 500,000. Next entry for December 31 to record the annual interest payment. We debit the interest expense of 1 million, which we acquired by multiplying the 10 million principal by 10% nominal rate. Then we credit cash 1 million. Another entry for December 31 to record the amortization of the discount on bonds payable using the effective interest method. We debit interest expense 49,310 and credit cash 49,310. And the amortization is computed as shown. Interest paid 10 million times 10%, which is equal to 1 million. Then interest expense of 10,300,000, which is the net proceeds, times 9.23%, which is the new effective rate, 950,690. Deducting the interest expense from the interest paid, we get the amortization of premium on bonds payable equal to 49,310. That would be all for this video. We hope you learned something from our discussion. Again, this is Account on Me. Thank you so much for watching and listening. God bless us all, and see you on our next video.
Let's learn together to achieve our dreams.